Now we'll take a look at question E, or part E of question 1. So we'll take a look at, again, vertical asymptotes. That's when the denominator equals 0. And if we solve for x, we see that we're in a situation here where we have x squared equals -1, and so we need to take the square root of both sides, which is fine for the left, but you cannot take a square root of a negative number. Therefore, there are no vertical asymptotes in this case. When we look at horizontal asymptotes, again applying the Bell-Gates rule of functions, we see that f as x approaches very large values of, as x approaches very large values, f of x is approaching x squared minus 1 over x squared plus 1. Again, the -1 and the +1 don't make any difference to the result, so you're left with x squared over x squared, which simplifies down to 1. So the horizontal asymptote is equal to y equal 1. Then we'll take a look to see if there are any x-intercepts and y-intercepts. So for the x-intercepts, those occur when y equals 0. And so you set y equal to 0 equal to x squared minus 1 over x squared plus 1. Multiply both sides by the denominator, and so you get 0 equals x squared minus 1. And you add 1 to both sides, you get 1 equals x squared. And take the square root of both sides, so you get x equals plus or minus 1. So those would be the two x-intercepts, 1, 0, and -1, 0. And we can plot those here on the Cartesian plane, -1, 0, and 1, 0. And also, we will then find the y-intercepts. That occurs when x equals 0, so f of 0 equals 0 squared minus 1 over 0 squared plus 1, and that just gives you -1. So the y-intercept is y equals -1, which in coordinate form is 0, 1, or 0, -1, sorry, which I will plot right there. So the no vertical asymptotes, we've got 3 intercepts, 2 x-intercepts and 1 y-intercept, and then we have a horizontal asymptote at y equals 1, so we can plot or show the horizontal asymptote there, and so you should get a pretty good idea of what the graph looks like given the information that we just found. So this graph does a little upside down bell thing here, and that occurs because of these x squared terms over here. Okay, so now as there are no vertical asymptotes to analyze, so we can say as x approaches -infinity, f of x approaches 1 from below, which is what happens here, approaches 1 from below, which is the horizontal asymptote. As x approaches, sorry, that should be approaches -infinity. As x approaches positive infinity, f of x approaches 1 from below again, as we can see over here, is approaching from below. And then for part 2 of the question, finding the limits, the limit of f of x as x approaches -infinity equals 1, and the limit of f of x as x approaches positive infinity also equals 1. And now let's move on to the last section of this question, question F, and the function is x over x squared plus 1. Again, vertical asymptote. Well, the vertical asymptote, the denominator is the same as was in this example here, and we saw that there was no vertical asymptote in that case because we can't take the square root of a negative number. So we're going to say that there are no vertical asymptotes in this case. Horizontal asymptotes, we're going to, again, as x, analyze this as x approaches very large values. The function f of x approaches x over x squared plus 1. We know the plus 1 doesn't have any effect on it because these are very large values of x. And we have x over x squared then, which simplifies down to 1 over x. And then if x is really, really large, 1 over x simplifies down to 0. So the horizontal asymptote is y equals 0. Then we'll look at any X-intercepts, and those of course occur when y equals 0. So 0 equals x over x squared plus 1. Again, multiplying both sides by the denominator to clear that out, so we get 0 equals x. So the X-intercept is 0, 0. I'm having a feeling that the Y-intercept will also be the same, but we'll just go through this process just to make sure. So x equals 0 when we're looking for the Y-intercept. So f of 0 equals 0 over 0 squared plus 1, which gives us 0 over 1, which indeed is 0. So the Y-intercept is 0, 0. Okay, and so I didn't prepare this before. We'll have a little Cartesian plane here. And we have the x and y intercepts at the origin. There are no vertical asymptotes. The horizontal asymptote is 0, which is the x-axis. So this is going to be an interesting little graph because I don't really know how to what to do with this. However, I believe from plotting a couple points here, choosing a few values of x in this, I noticed that the graph goes something like this. It comes up and then down, approaches the horizontal asymptote of the x-axis, y equals 0, and it does the same thing here. It dips down and then back up, approaching y equals 0. So that's what the graph looks like. And so then we just analyze it by looking at a couple parts of it. And so as x approaches negative infinity, f of x approaches 0 from below. That's coming up from below here. And as x approaches positive infinity, f of x approaches 0 from above, which would be this portion here. And then we take a look at the limits in part 2, the limit of f of x as x approaches negative infinity, that equals 0, and the limit of f of x as x approaches positive infinity also equals 0. So that concludes question number 1 from section 14b.